So yeah, my name is Timo Grossenbacher. I am from Switzerland and I represent the Swiss broadcast, which is basically the same as the BBC, but just smaller. Oh, it expanded. Great. Okay, so yes, and the slides are on Google Drive, so you can write down that and they'll be accessible later or right now. So what we do is, well, I work for this small team. We're called SRF Data, and we're a team of 3 people. And our main publication channel is this URL. So we have quite a variety of stories. We had stories on state surveillance. We had stories on a new referendum about energy strategy in Switzerland. But we're still a broadcasting company, which means that we also have to bring our stuff to radio and TV. And there's always that question I get, how can you show a data viz on radio? Of course you cannot. You can't even show a data viz on TV. That doesn't really work because it's not enough time. So basically we have like an overview. We have the whole story in the web. We have like interactive data vizes in the web. And then we look for anecdotes. We look for the outliers, for the interesting stories. And we bring those in those broadcasting channels just as we did that 20 years ago. So what is data journalism? And last year at useR there was a talk by Andrew Flowers working at 538.com. And he had this definition, it's empirical social science on a deadline. And I wouldn't fully agree with that, but I don't want to go into definitions either. I just want to show you some examples of data journalism at our place and also at other media outlets, and of course how they use R. So this is an example by us. What you see here is a so-called dual-use good. This plane can be used for civil purposes, but it can also be used for military purposes. You can mount machine guns on that, and that has been done in the past. And it's a really good plane, and it's manufactured by a Swiss company, and they make a lot of money with that plane. But these dual-use exports are a bit some sort of controversially discussed in Switzerland. So I think in 2014, the government was forced to release data on exports. And what we did is we took that data and we just made this really simple interactive database so you can filter for years. You can look at the destination countries of those exports and you can look at the categories of those goods. So for example, we have planes here, which are the most prominent category. We have simulators, we have sensors and lasers, communication equipment, etc., etc. So I want to show you the process we had. We went through for that project. And as you can see, so that's the raw data, right, from the government. And in the left column, for example, you have the country. And then you have countries like China, Taiwan. And it's not China and Taiwan, of course. We wouldn't export the same good to both countries. That wouldn't be possible, probably. So that's just the naming they have in those spreadsheets, and they're not really consistent. And also you have this complicated alphanumeric sequence here, and that's called the signature, and that's basically the category of those goods. So we had to parse that. So what we did in our R script was that signature parsing. Just take it apart. I mean, you could do that in any other programming language too, or scripting language. This is just regex and look and see and try if it works or not. So that was quite tedious. And then we have that naming, that's country names, that's standardization. And of course, this is pretty verbose. So keep in mind, this script is 3 years old. Nowadays, I think you can do that with dplyr and case when. I heard that's pretty new. So, but you can see, for example, China, Taiwan is recoded to Taiwan, right? So that's a very important step. And then also in the same script, we did some exploratory data analysis. For example, here you see that for the year 2016, I guess, India was the country with the most exported goods in the volume of 300 million Swiss francs, which is about 300 million euros at the moment. Yeah, we also did that. And the punchline here is actually those data are released since 3 years, and in these 3 years we had like 3 stories. Well, we first published these 2 together, I guess, or no, that was the first one. That was just a general overview of that business. And then for the year 2015, we found out that there were more exports to the Near East, which is quite remarkable, because that was the time when the Yemen conflict started and Swiss companies were no longer allowed to export conventional arms and weapons to the Near East. So they just raised their exports of dual-use goods, which are not so strictly regulated. And then 1 year later, we did another story about Iraq, the first deal with Iraq ever. And the thing is, we could only do those stories because we had everything scripted, we had everything automated. And once those data gets out, a lot of journalists look at it, but we can run our script, and it'll parse everything, it'll produce a markdown, and we can look at the plots, go to our broadcasting partners and publish that. So we have that comparative advantage because of automation. And also, if something changed in the data, we have those error detection routines. Another example I want to show from us very quickly is a story about commuting. Switzerland is a commuter's country. We have millions of people commuting every day on our train network, for example. And we had this interactive, it's not investigative at all, it's just an interactive, where you could have a very personalized view on your personal commute and compare that to whole Switzerland. So what I did was I made these animated maps just to have some sort of eye candy in the interactive. I have to admit that. But of course, it was also very fun for me to do, because I did those maps in R. Those are basically frames. I think each animation has like 60 frames, and each frame is a ggplot with G on point, I guess, and then there's the challenge to make it look smooth, etc., etc. So, and in this example, also we have that R pipeline where everything is in one script, so that there's the data acquisition via the Google Maps API, because we need to get these routes where exactly those trains drive through, and then some minimal data wrangling. And in the end, I have these 60 ggplots, and I stitch them together with image magic, of course also from within R, because you can have system calls to other software, and then the rendering is done in the web via CSS3. I could also have produced GIFs that would have also worked in R, but then the GIFs were too bloated. So CSS3 was more performant. A completely other story from somebody else, from ProPublica in the US, which I find is one of the best examples of data journalism in the last few years, if not the best. And it's called Machine Bias. And the punchline is, the lead is their software used across the country to predict future criminals, something like Minority Report, but it's biased against black people. And what they did is, what this algorithm does, what this software does is, it attributes a score for defendants and people in jail. So that score will predict how likely somebody is to reoffend once he or she is released from jail. And ProPublica, so those scores were public, or they FOIA'd it probably, got it out from the government, and they looked at the scores in the very beginning, just like looked at the scores, and they came up with this plot, which is of course ggplot, as you can see. So on the left-hand side, you see the black defendant scores from 1 to 10. 10 is the most likely to reoffend. On the right-hand side, you see the white defendant scores. And Jeff Larson, who was involved with the story, told me personally that once he saw that plot in the very beginning of their research, they already knew they had a story. I mean, if you look at the distributions, the black defendants' scores are almost uniformly distributed, and the others are more like long tail distributed. So there must be something fishy, right? So, and what they also did is they calculated those false positive rates, false negative rates, and as you can see, you can look at the story later, but there's also some sort of inequality. And the gist of it is that they released their story, of course. They also released a very verbose making of, and they released the whole code and data associated with that. So everybody can reproduce it, and that was really necessary because that company who makes that software, they attacked ProPublica and said, well, your analysis is completely flawed, right? You did the wrong thing and our software is perfect. So ProPublica could say, well, look at it, it's online, and also I think quite a lot of scientists looked at those repositories and at those data and came to the same conclusions as ProPublica, so it really helped them. And a similar example, the last one I'm going to show, is from a German outlet, so Der Spiegel, which you probably know, and Bayerischer Rundfunk, which are some sort of the equivalent of us in southern Germany. And what they did is they created two fictional characters, Hannah and Ismail, and both are Germans and both have exactly the same qualifications, but Ismail has a not so German sounding name, right? So what they did is they scraped apartment advertisements from some platforms, and they sent out 20,000 emails. I think they even did that in R. Sent out 20,000 emails to those people advertising those flats, and with exactly the same application by those two fictional characters. And Hannah got a way more higher response rate, got way more invitations to look at the apartment than Ismail. So that's a story that could only be done with automation and scripting and stuff. And also here, the same thing, they also released the R Markdown for the story. And of course, how I said it now is really like brief, but I mean, they did a whole lot of other different statistical analyses. They also consulted with statisticians, and I mean, if you look at that, there's almost no chance to attack that story. I mean, that story is really bulletproof. And if they hadn't done that, no chance. So that's the last point I want to make. It really gives us the ability to be reproduced by others, to be questioned, and also held accountable. And I think in data journalism, that's one of the main reasons R is used more and more, because I mean, you could do it in Python too, and what I see from my perspective is R is gaining more and more traction in comparison to Python. And maybe to the point of the reproducibility, one last link. We have this GitHub page, srfdata.github.io, where we publish most of our stories where we have an R script. So there's always a repository, and then there's always a data description, which is basically the knitted markdown. And maybe a little side note, doesn't have a lot to do with data journalism, but and there's some other talks on that problem. But the thing is with reproducibility as it's done today is that actually those markdown scripts are mostly not really reproducible, because always the latest package version gets installed, and then when I dig up my 2-year-old scripts and try to run them, they always fail. Or they don't fail, but something in the output changes because of other package versions. And what you should do is, you should try to use Checkpoint or Packrat, or there's some of these other packages. And yeah, I have this template on GitHub, and there's a blog post on my website, so if you want to see how that works, check it out. Yeah, so I come to my summary. R is gaining traction, that's clear, and I would say the greatest benefits are automation and reproducibility. And even though it is mainly used for data cleaning and EDA nowadays, it's more and more used for really sophisticated data analyses, like from ProPublica or Der Spiegel BR. So that's getting more and more science-ish, I guess. And the challenge, of course, is we need to get journalists to code. I say code in quotation marks because with the tidyverse nowadays and dplyr, it's more like a declarative language, and that really lowered the barrier for journalists, I would say, which is cool. And then there's RDDJ Info. That's another shameless self-promotion. But I made this just a collection of tutorials for data journalists. And it should be interesting for data scientists too, because there's really good tutorials on the net, and I try to combine them. That's it. Thanks for your attention, and I'm happy to answer questions.